evening, Art.
So, good afternoon, ladies and gentlemen. I'm the last one before the lunch, so I try to manage the time. So thanks Hithium and Zing for the great event. I would like to talk about the challenge and solution for the stabilization of grid with high renewable penetration. It's just like the people talk about. Now, more and more renewable is integrated in the grid, but they have the challenge how to make the grid stable and reliable. Definitely the battery storage is one of the solutions, but how you can manage and control the grid to make it available, it's still a lot of the challenges we need to face. So we know the electricity transition for the forecast for the 2050, there should be more than 90% of the renewable, more than the 60% to 70% of the variable renewable in the system. So we call it a new generation of grid. We face a challenge. Here we list some of the main challenges for the new generation of grid. It's like the transition to the low emission generation source, and also the increased customer penetration in the grid market, and also the integration of the digital and communication technology, rapid electricity of the transportation and the building, and also for grid resilience. For the challenge we are facing, the first one is increasing generation uncertainty. You know, for the conventional power plant, we have the big coal-firing power plant, gas turbine or hydro. It's reliable and stable. But now they change to the renewable. For the renewable, you know, they should have the technical challenge as the energy transition. Developed with the how many percentage of renewable in the system. So for this diagram, we list all this kind of technology we can develop to try to solve the problem. It's based on how many percentage of the renewable in your system. If you're less than the 10%, there is a small impact for the system. With the more and more, I just see the data in Israel is more than 40%, right, for the renewable. So you need a more power system stable for the transition, regulation, and control. It's like from the HV and LV right through all the frequency and voltage regulation, and also for the synchronized condenser application and a grid forming technology should be approached in the system. If you have the 100% of the renewable, there should be high requirement to keeping the essential characteristic of the AC power system and how to keeping the short circuit capacitor, innovation of the rotation initials. You know, the main characteristic for the new generation of the power grid is more inverter-based resource in the system, like the PV inverter, the battery inverter, it's a PCS. So we need to keeping the frequency and voltage stable because it became the more critical. So this diagram is from the SIGRI. They list some of the new stability consideration. You know, for the right side is for conventional grid. So we need to consider about the voltage, frequency, and the rotation. Now, with the more inverter-based system, so we also need to consider about the converter driver stable and also the resonance. If you have so many kind of the inverter in the system, you need to manage and control all this kind of the big inverter column. You need to consider about how to prevent resonance. So the left side lists some the solution. Like for the traditional way, we have the synchronized machine. It means use the same as the generator, but only generate some active power and reactive power, give you support. This is some the physical solution. Another one, for the conventional renewable integration, we use a grid following, like the PV inverter and the battery storage inverter. It's a grid following. It's following the current of the grid. So if you lose you have some disturbance, like you have some bad weather or you have some emergency happen, they should be disconnected very quickly. It already happened in many countries, like in Australia, in the Europe, in US. When you have the high percentage of renewable, if you face the challenge, you will be cascading, disconnect the grid, make it blackout. So we are trying to develop the grid forming technology. Means we change the inverter control technology to the voltage support. It's something like the conventional generation to support the grid to make it reliable. So this slide will list some the architecture of the active power and frequency. When they have some emergency happen, there should be multiple time scale response to support the voltage and the frequency. It's like you need instantaneous response, and also you need to provide an initial response to support the system strength, fast coordination control, and state-state organized control. So based on all this kind of analysis, NR, we developed the grid forming solution for the new generation of the high penetration of the renewable. It's not only for the battery storage. The grid forming solution can meet the key challenges such as the system strength, voltage forming, initial contribution, and the frequency control. So we can provide the grid forming definitely for battery storage, and also the grid forming for the HVDC, grid forming for STARCOM, grid forming for the PV. So use the grid forming technology to support this, I think, the high penetration of the renewable grid system. So why NR for the grid forming? We have the experience for the power electronic solution more than 20 years, more than 30 years for the power grid control and protection, more than 20 years for the power grid EMS and SCADA, and also more than 10 years for the battery storage integration in the installed capacity more than gigawatt. NR's battery storage is a comprehensive integration control, protection, and energy management. So we call it 4S solution. It's including the top level energy management system that can optimize the operation and the monitoring for the whole system. The second layer is the power management system. It means if you have the very big battery project, you have more than 1,000 PCS or inverters. So you can use the PMS to coordinate, control the multiple PCS to respond to prevent some of the resonances and others happen. And also we have the PCS. The PCS can add it with the grid forming technology, so they can bi-direction power flow control to provide active power and reactive power support. Also have we call BMS. It's a battery management system to try to manage the battery cell to utilize its more efficiency and safety. So we have the 3 different kind of solution for the battery storage. One is liquid cooling battery integrated cabinet. Means in the one cabinet, we combine the battery cell and also PCS, so they can directly output AC to provide the power. The second one is centralized and modularized PCS. I think I'm talking with some people during the coffee break. They asked me how about the future for the battery storage, especially for the PCS side. Based on our experience, we are considered about they go for the two directions. One is they have the bigger and bigger battery cells and the big battery containers, so they should have the bigger PCS. This is the economy solution. Then you can provide the big system. Another direction is we also develop the modular PCS. Means modular PCS can combine with the battery cells. It's like some kind of a modular system that easy to be extension and maintenance. Also, based on the power electronic experience, we have developed the HV directly connected battery storage. It's something like the Stockholm, means they don't need a transformer. They just use the more edge bridge cascaded topology of the IGBT to directly integrate the battery in the system. Means with the edge bridge, they directly connect to the HV side, so they don't need a transformer. The advantage is they should be increase the efficiency, and also they will more efficiency to utilize the battery and also for the converter system. So this is the centralized PCS. We already have the PCS up to the 1.75 kilowatt. Now we are working for the 2.5 kilowatt single unit PCS to be released by this year. And for another one, it's just I mentioned about the modular PCS. We already have the modular PCS, is the 186 kilowatt. Now we have the new module, is 215 kilowatt. It's a liquid and air cooled. So here is some comparison of the different scheme. This is the popular scheme on the market. One is the centralized PCS. The advantage is the cost, and also the complexity is low, response time is fast. I think some of the disadvantages people consider about it, how to do the capacitor expansion. And another one is central PCS at DC and DC. They have the easy to do the custom management, but the cost is higher, and also the efficiency is low compared with the others. And also they have the string PCS and DC-DC. They have also here list some advantage and disadvantage. And the last one is the modular PCS. I think the cost is medium, the complexity is low, and response time is faster, and the battery coupling is higher. So here is some of the comparison. You cannot say which one is the best. It depending on how about your application case for your project and for your system. This is a high voltage directly connection battery storage PCS bar. So it's something like the for the HVDC or the flexible AC system. They use the edge bridge to connect the battery directly to the bridge. Then they'll do the converter. So it's not only for the batteries in this kind of solution. We can also use the supercapacitor in this scheme. Means when you have some very quick action for your high-speed frequency regulation or the voltage support, you can use a high supercapacitor. And if for the long times, you can use the lithium for the system. So here we list some of the advantages and application case for this system. It's best suited to meet the future technology for the high power, large capacity, high energy conversion efficiency, and the high control performance requirements. For this kind of the case, this is one solution. And also you can see for this kind of solution, the beginning investment is a little higher than that's centralized with the transformer, but the efficiency can be increased maybe 2 to 3%, and also the totally response speed. When you do the control, response speed can be less than 5 milliseconds. So here is talk about grid forming technology. This is a very popular topic now because it's just like what we talked about this morning. So when you have the high percentage of the renewable, how you manage all this kind of the challenge? So grid forming means they use the voltage and the frequency control for the PCS or the inverter to provide a reference for other device and control stability of the entire grid. So here is just some simulate. For the conventional grid, we have the rotation machine, like a generator. You know, for the generator, when you have some disturbance, the rotation has the initial. They cannot be stopped quickly. They need some time to slow down. So during this time, if you have some disturbance, this initial can be put it back if the disturbance is in the limit. But when you go for the 100% renewable, you don't have this rotation, no initial in your grid. So when you lost, you have some disturbance happen, you will be disconnected very quickly based on millisecond. So for the grid forming means we use the P control and the Q control for the PCS, just to simulate this kind of the conventional initials. But even they can more easy to management because you can control all this process. So here is the main features for the grid forming. You can find they can provide active power response and reactive power response very quickly. So here is some of the technical comparison for the different kind of technology. Like the first one, the synchronized condenser. Now, even in China, in Europe, in US, they are start to install more the synchronized, it's like generator, synchronized condenser to provide the initial support. The second one is, we call it star core, and also for the grid forming and the grid following technology. So you can find for the grid forming, they have some advantage to provide the synchronized support and the 4 quarters management and also the easy to management and control. So what we have do for this technology, we already implement 3 projects. It's in China. I will be giving you one case for this project to verify the grid forming technology. And also a lot of the project is in the execution. And also NR, we are working with some international group like SIGRI. We are the convener for the SIGRI working group B4. It's for the industry implementation and application of the grid forming technology. And also we are the active member with the UK National Grid to try to draft the regulation for the whole UK market to how to utilize or how about the grid code for the grid forming. And also we are involved to discussing with many different kind of utility and different country to try to develop some of the pilot project, verify how about this technology in the different system. So this is some of the engineering practice we already implement. NR Electric, we are operation and for the provider solution for more than 120 countries now. And also we have the solution not only for the battery storage, we have the whole line of solution for the power protection, control and automation, like the whole line of the line protection, generator protection, and also distribution protection, also the management system for the big system, and also for the power stability control system. Means it not only for the protection relay for the one line or one transformer, we also have the solution to how to protect the whole big system, like the Israel or like in China, the big grid system. So you need some kind of the solution to give you some the protection, especially for some the disturbance happen. For example, you lost one big generator or two big generator, or you lost two lines. How you make more customer available for your system? So we have this kind of solution we call power stability control system. The second one is HVDC and FACS. It's based on power electronic technology to how to use the power electronic components to give you some conversion for the HVDC and also for the flexible AC. And the third one is for we call the renewable and battery storage and microgrid. So based on all this kind of the technology combination to provide the whole total system for the battery storage and microgrid. So here is some of the case we already implement. This one for UK, the 100 megawatt battery storage. We provide the PCS, PMS, and EMS. They provide the support grid and for the electricity market. This one is South Africa. This is the biggest battery storage in the South Africa. We already commissioned it the end of last year. This is the one project I would like to talk about. We just implement this project the end of last year. So this is in the west area of the China. Here we list some of the information for this area. This is a big area but less population. The totally peak load is 75 megawatt, and the local grid they have more than 490 kilometers transmission line from the east to west. So the challenge, the problem for this grid, they only have the one 220 kV line, single line, with the 440 kilometers to connect to the grid, and a lot of renewable in this system. So when they lose, this is long line and big line. So when you lose this line, you lose the system. It not means you do nothing, you can make the system available, even you have enough renewable. So what we do, we are developing, this is we call the whole system to control. We added two battery storage actually. We need some resource to regulate. We added two battery storage and also including all this control and management for the PV, for the grid. So here I list all this kind of the system, not go for the detail. So how about the challenge, goal for this project? We want to achieve for the zero power outage, and also we want to achieve the 100% renewable. Actually we do it. We have implement and verify the 100% of the renewable for more than 48 hours. And also during this period, also they simulate some of the fault happen, like the light tripping or you disconnect with the PV. And we still try to make more percentage of the customer is available, even for some of the black start. Black start means if you lose everything, how quickly you can reconnect the grid as soon as possible. So this is just one case to verify 100% renewable is possible, but definitely they still have a lot of challenges we will go to solve, like how to coordinate, how to make the whole economy. So I think we can work together for the different kind of the case to try to develop the solution for this kind of the regions. And this is for one application for the battery storage. In the gas turbine, we install the battery storage in the one, I think it's a very big gas turbine. It's a 9F class gas turbine to provide the black start and the frequency regulation. Means when this, when you have some problem happen, so this battery storage can support this gas turbine. This one is for this is not for lithium. This is for the VFS. It's a flow battery for the 100 megawatt project to verify another kind of the battery storage technology. And also this is for the centralized PCS with the liquid cooling cabinet. It's just like what I show you, the cabinet integrating the battery and PCS, so make it integrated to the medium system. This is for the wind farm storage integration. And this is for the solar power plant integration. This is for the HV directly connection system. We already commissioned, I think the highest voltage is 35 kV. We directly connect to the 35 kV without transformer to provide the service for the system. Thank you. So this is for the grid forming application case. This one is in China, and I think we have 3 projects, 2 already commissioned, 1 is in the process. Okay, thank you.